Hello, boys and girls. We are at lesson 10 in grade 8 mathematics. The topic is actually your mixed triangles, not only right angle triangles, but mixed triangles. Now we're looking at classification of these triangles. Now, the different types of triangles, one is we can look at the angle, the size of the angle. Acute angle triangle has each angle less than 90 degrees. So the triangles are more or less pointed because each angle is less than 90 degrees. The angles are sharper. Each angle is less than 90 degrees. Now right angle triangle, one angle, this one angle is right angle. You can only have one right angle, but that's 90 degrees. So one angle is 90 degrees. Obtuse angle triangle, one angle is greater than 90 degrees. So you'll have one wider angle. There's a wider angle. So this angle here is greater than 90 degrees, as opposed to your acute angle where the angles are less than 90 degrees. All the angles here are less than 90 degrees. Obtuse angle, one angle is greater than 90 degrees. So that's the measurement of the angles. So we can classify triangles. It can be one of these three here. Now, you can also classify a triangle with one of these three here. Right, so one of these three. We're looking at scalene triangle where all sides are unequal. In a scalene triangle, all the angles are also unequal. Same rule applies to the sides as well as the angles. In an isosceles triangle, two sides are equal, which means two angles are equal as well. Equilateral triangle, all sides are equal and all angles are equal. So no sides are equal here, all unequal, and obviously the angles are also unequal. Two sides are equal, so two angles are equal, and three sides are equal or three angles are equal. So this is one form of classification. We have one form of classification here. That's one form of classification. And then we have your other form of classification here. So this is based on the measurement of the angles. This is based on equality, whether it's equal or unequal in terms of the sides of the angles. Now we look at the application that we have. The application states that we need to name the angles. We need to, name the triangles. Right? So we need to name the triangles. It says here, classify by name these triangles according to the given properties, and each of them will have two answers. So the two answers we are talking about is that there will either be one fall in this category, you'll get one answer from this category, and you're going to get a second answer from this category. So looking at the size of the angles, we see already a 90-degree sign here. So this triangle here is a right angle triangle. So that's the first classification of the triangle. Now let's look at what's equal. If you look at the sides, we have one stroke, we have two strokes, and there's nothing here. So the three sides are unequal. So if they're unequal, it'll fall under scalene. That's a scalene right angle triangle. Scalene triangle and right angle triangle. Now in 2.1.2, if you look at the angles, because you can't measure, you can check, you can see that this angle is a wide angle, but it's stated here. Angle Y is greater than 90 degrees. And since it's stated that this angle is a wide angle, obtuse, greater than 90 degrees, it means it falls under obtuse angle triangle. So from the three here, it falls under obtuse angle. Now we're looking at the next three. We're looking at the measurements. In terms of measurements, we have three different types of marking, which means the three sides are all different. So here again, we have a scalene triangle. So there's a scalene obtuse angle triangle. Now look at 2.1.3 in terms of the sizes of the angles, or in terms of the size of the angles. There's no 90-degree angle, and it says here H, G, and W are all less than 90. It means all the angles are less than 90 degrees, so it's going to fall here as in acute angle triangle. And we're looking at now what's equal in terms to get the next property, the next property, yes, what's equal. So one is acute angled. Now in terms of whether it is scalene, isosceles, or equilateral, we look at the sides. There's no sides, but we do have three unequal angles. And three unequal angles implies also unequal sides. So again, we have scalene. In this triangle here, it also gives you all angles are less than 90 degrees. And in terms of sides, there's no markings, but we have two equal angles. And remember, two equal angles here falls under isosceles. So for each application here, for each example, you need to state the two properties or two types of triangles that you have in each question. Now in question 2, you are required to find the size of the sides or angles that are marked. In this example, you find the value for angle A using one of the properties in terms of the property sum of angles of a triangle, whether it's an isosceles, whether it's an equilateral triangle, keeping all that in mind. Could be a right angle triangle. Using those facts, you need to solve for angle A, you need to solve for angle B. But the main idea in all this is that the sum of the angles of a triangle is equal to 180 degrees. And we have measurements here, so you need to, side measurements, so you need to find the angle CD, and you need to find this value for E, using the facts you pick up about triangles from this information that is given and from other lessons, work done in other lessons. Please note when the markings are like this, it means all angles are marked equal in this case. And here we also say that these two angles are marked equal. Boys and girls, enjoy your application.